In this video, we will look at mammal evolution as our continuing study of mammals. The mammals have the most documented transition in vertebrate history, meaning we have more fossil evidence of mammals than we do of any other group. They first arrived around 150 million years ago. Most of the fossil record for mammals is skulls and teeth, but you can tell a lot about a mammal by looking at its skull and looking at its teeth, the kind of life it lived, and so forth. The mammals are the direct descendants of a group of reptiles known as the synapsids. We talked about synapsids. These are animals that have a skull with only one opening. This is the temporal opening. The skull opening provides attachment for jaw muscles, which in mammals, this has become more and more pronounced. So let's look at the synapsids. The synapsid skull is the middle of the two there. Of course, diapsid at the bottom and then anapsid at the top. The synapsids were the first amniote group to inhabit terrestrial habitats. So these are the first reptiles to come up and inhabit the solely terrestrial group. The earliest synapsids were called pelycosaurs, and pelycosaurs were among the largest amniotes in the early Permian period where they were. They outwardly looked like lizards, but they had a different kind of way about them. And then from this group came a group called the Therapsids, and the Therapsids are the only synapsid group to survive the Paleozoic era. Their limbs, as you can see here in this pelycosaur, this is like the Dimetrodon and some others. You can see here the limbs are positioned more under its body as opposed to out from its body. You also see the same in the Therapsids. If you didn't know any better, you might think that this was a mammal skeleton because of the strongly developed pectoral girdle and pelvic girdles underneath its body, more like a mammal. The cerebellum become much more enlarged because what happens as you position your limbs under your body, there's more of a need for coordination because when your belly's dragging the ground, you don't need a whole lot of coordination to stay balanced. But when you're standing up on your arms, of course, it needs a lot more coordination. The cerebellum is what's doing this. The jaw connections increased in efficiency, allows for more chewing, and this radiated into numerous kinds of herbivorous and carnivorous forms. The next group then to come from that are called the Cynodonts. And these are a group of therapsids that survived into the Mesozoic era. They have an increased metabolic rate and much more specialized jaw musculature, skeletal changes that increased their agility as well. And they have heterodont teeth, which allowed for better food processing instead of just the standard sharp little jagged teeth. They have more processing power in those teeth. Turbident bones, like mammals, that allow body heat retention, and they have a secondary palate, like mammals as well, that allow them to breathe and eat at the same time. This allows the young to breathe while suckling. And they have a loss of these lumbar ribs, which is what you also see in mammals. The lumbar is the lower back region. This allows for the evolution of the diaphragm, which is a better way to use the lungs, and also allows for more dorsoventral flexion. So kind of like what you do if you are laying on the ground and like lift your torso off the ground, that sort of flexion. So here's what they believe those primitive cynodonts probably look like. And this is the earliest precursor to mammals. The first mammals then were these tiny shrew-like animals. They had diphodont teeth, they had hair, they were endothermic. This radiation happened after the Cretaceous extinction event. So those mammals were around before then, but after that happened, what all of those extinct orders of reptiles left open niches. And of course, you have an adaptive radiation where the mammals rapidly filled those available niches. And it would make sense then some of the first mammals that started to fill those niches ended up being very large because they were replacing niches for very large reptiles. And you see that here. I put this, of course, our T-Rex screaming at the meteor there happened around here. And so here's this ancestral cynodont, which is probably around the first mammal and the common ancestor for all mammals. From that, you have modern day monotremes. These are egg-laying mammals, very few species. And then later, in that branch, you have the marsupials that branch off from the placental mammals, which are most mammals today.